Hello, I thought I'd do a quick video on a small project I'd done. It really didn't take much time, but it used to cause me a lot of time wasting, and it's something to do with the things as simple as a resistor. Often when I'm prototyping a circuit, I'll use something like this, and you'll always see, or certainly in my case, I'll always see, I've got lots and lots of resistors lying around. So I have often on these boards, I've got them lying around the workshop here, and I'll have them often out. I've got a big store of them just on one of the top shelves there, and I'll get resistors out. They're organised so I can get them easily and so on. But what I find is, when I finished a project, I would have gone through quite a lot and changed the impedance of a circuit or so on, which will often involve changing varying resistors and so on, various resistors. So at the end of each sort of session, I'll end up with a small pile of resistors. Now, sometimes, I've got the time and inclination to put them away and put them back in, but more often cases I haven't, so I just throw them away. And one of the things I thought would be really nice to have is a resistance decade box. Now, they're quite interesting because they are available, and they're available in all sorts of ranges, but they're actually expensive. And here's an example of one here. This is one I bought not so long ago, and this is a really great. Let me try and get that over there. It's a really great resistance box. You can see the tolerance is 0.05% across the whole range, apart from the 100k range, which I think is 0.1%. There we go. These are really good, and obviously they're quite expensive. I think this was about £150 second hand. I think they can often sell for £500, £600, £700, and they're really useful for certain things. Particularly, if you're testing a multimeter or you're verifying a multimeter, or if you need precision resistance for a circuit to check something, then they're all they're perfect for that. But they are bulky, they're big, and so if you put these next to, you've got this here, and that's you're working on a circuit here. Well, that's great, and you've got one of them, and maybe if you're lucky, you maybe stack 2 or 3 of them, and if you need more than 2 or 3, really they're not an option. And also because they're quite precise, what you don't really want to be doing with it, because they're precise and therefore they're expensive, what you don't really want to be doing is experimenting with these, especially when you've got high current or high voltage circuits, because you can damage them really easily, and if they're really difficult to repair, because I think a lot of the resistors inside, and I'll take this apart in a minute and show you what's inside. They're not just normal resistors that you buy. A lot of these are wound using resistance wire, and they're hand wound for each value and so on. So they're pretty difficult to fix once you damage them. So a cheaper solution is often, for specific, for more generic work, would be a lot better option. Now, I had a look around, and I really couldn't find anything that was cheap. I found, I think there were a couple of units that were maybe £100 or £120 or something like that, but really quite expensive for what it is. Okay, I've removed the screws in here, and I thought I'd show you what the inside of these things look like, because they might not be what you expect to see if you're expecting to see a bunch of resistors behind some switches here, because you'll see something quite different to that. I would say be very careful when you take these out, because because there's such a long, I mean, they're quite sturdy, but they're big long things. You can definitely damage this quite easily if you're not careful. So let's have a look at this and see what this construction. Let's see if I can get this better view. So, okay, so the first thing to note is look at the quality of the switches. You've got a multi-leaf. I think it's a brass contact, multi-leaf brass contact. These are very akin to the old Strauser exchanges. They're designed to last literally forever. You would have to do an awful lot of operations on this to get them to fail. You'll also notice they're make before break, and I think that's by design, because obviously you're switching over from one resistor to another. And they're quite, these are obviously, these switches are not manufactured en masse. These are not mass production switches. These are almost handcrafted. These thick bits of, I'm not quite sure what kind of material that is, kind of like that resined paper, I think, that kind of material. But they're obviously machine engineered out. The whole thing is almost hand machined. That's what it feels like. Now at the at the high end, at the higher resistor values, you'll notice that there's essentially off-the-shelf precision resistors. I think these are made by, let's just have a quick look here. I think they're made by, I can't see a manufacturer on there, but they're 0.1%. I'm not sure if they're wire wound. They're almost certainly wire wound construction of some form in there. You know, but they're obviously not particularly cheap resistors. But then when you get down to these lower ranges, you can see what they've got. Basically, for each decade, there's 5 of these bobbins, and you'll see that each bobbin is made up of 2 parts. So each one of these makes up a resistor. And effectively what they're doing for each resistance value, they're taking a certain kind of resistance wire. I presume each type of wire will have different resistances per inch or whatever it is. And they're hand winding each one of these to get the exact resistance for each decade. So this is not something you do on a machine. This is something you do by hand, and you check it. And you can see that as you get down in the lower ranges, there's less wire and the wire's getting thicker. And you'll often see things like this where, there you go. Let's see how you can see that where the wire has been a little bit longer than, you know, it's precise. It's very, very precise, the lengths they get to. And obviously down at the 1 ohm end, you can see here that the wire is actually very, very thick. So down at the low power end, the low resistance end, it's able to handle more power. And that's why you'll find that each decade here, I'm just trying to handle this carefully, give me a second. You'll see that each decade is rated at a different power handling. So the 1 ohm is rated at 750 milliamps. The 10 ohms range is rated at 120 milliamps, and 40 milliamps, 12 milliamps, and 4 milliamps. So as it goes up in ranges. The other thing about this construction is it's big. You know, there's a lot of air around all the conductors here. So these actually work pretty well for high voltage testing as well as low voltage. If you're working on tube amplifiers or, you know, other things where you've got quite high voltage, you can actually use these kind of resistors for that. Clearly, you wouldn't use you know, the small ones made out of switches or that kind of stuff. You would try and use these when you've got high voltage. Anyway, I thought it'd be interesting for you to have a look inside that. If you haven't seen inside one of these before, that's what they look like. They're quite intriguing. The problem with them mostly, as I say though, for normal prototyping activities, they're just very, very, very big, physically big, and therefore you have a lot of space issues. Well, certainly unless you've got a huge bench. Now, I came across a project, I think I found it on the EV blog forum and also on Hackaday, and I will put the links in the blog post that goes along with this video. But I'd found that someone had got hold of some of these, which you can buy on eBay really cheaply, and made a decade resistor. So I thought, actually, given they were cheap, I think this was about $6 or $7 for 10 of them. I thought, you know what, I'll give that a go, because I think I'll make something as small and as convenient as that. That'll be a really good addition to my tools here. So now I think the original project used normal resistors, normal quarter watt radial resistors, and you know, space is a real problem here. And also, I wanted to make something that was perhaps more repairable. And looking at it, I figured I could construct something just using surface mount resistors, 0805 surface mount resistors. So what I'm going to do is I'm going to go and give that a go. I'm going to build one of these now. It shouldn't take very long. I'm going to build a 7 decade resistor, and give it a quick test. So I'm just going to go do that. I will video it and then I'll speed it up so you don't have to sit through it. Okay, so I'm going to go and do that now. Okay, so there's the 10 resistors soldered into the 9 resistors soldered into place. Now all I need to do is place a link wire between the two ends there, and that's the 1 meg ohm range done. Okay, so resistor values. This is 1 meg, 100k, 10k, 1k, 100 ohms, 10 ohms, 1 ohms, in that order. That gives us the seven position decade. Right, just solder these up. Just going to use a bit of tape just to hold these together while I solder the backs. Basically going to cascade the 0 to the column, 0 to the common, and then 0 to common, 0 to common, right the way through, just to basically wire the switches in series. Very simple. Okay, so that's wired now. Very, very simple. Just a couple of hookup wires to, and then we'll give it a test. Okay, so I've put this one together, as you saw. Now the components. I'm going to try to see if I can get focus on here, but the components are really small, and you can see them. Actually mounts on the board nicely. I have to cut one track. I will take a couple of high-res photographs, but it's pretty easy to cut. Just use a drill bit and cut the track. I can get 10 resistors on there. 9 resistors on there, and there's a wire link across the back of each one as well, which you can see, and then there's a wire link going between each one. And I've tried that and that works fine. I think the resistors I've used are 5% tolerance. That's what I've got in my resistor store here for those resistors. And obviously for each decade it starts as 1 ohm resistors, 10 ohm, 100 ohm, 1k, 10k, 100k, and 1 meg. So that gives me a range of 0 ohms through to 9.999999 meg ohm. In 1 ohm steps, and it's pretty convenient. It's quite small, what I'll do, I'll show you just dialing in a couple of values now on a multimeter, so just so you can see how convenient that is to use. Okay, so I've got that hooked up now. You can see it's set to 0 here. It's reading about 0.8 ohms, and I suspect this is obviously the wiring, the contact resistance of this thing. These are not the best quality switches in the world, and obviously the resistance of the leads and so on. So just for the purpose of this demo, I'll just put this into relative mode. There we go. So we're at 0. So I should be able to dial in 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms, and so on. So that's great, that works nicely. 10 ohms, 110 ohms, 1100 and... Oh, now what's happened here is the meter's gone out of range because it's in relative mode, so I'll just drop that out. Okay, 1k, 2k, and so on. So 10k, that's 14k, 24k, 34k, 134k. Obviously the tolerance of the resistors that I've used now is starting to come into play here. 234k, 1.234. Let's just dial that up. Let's see, we're probably quite a lot off now. Okay, so basically that works okay, and it gives me a basic working decade resistor. Now, so although that works, and definitely very, very useful. It doesn't cost very much, $7 or $8 or something like that to build. It does take quite a bit of time. There's two things that worry me about. First of all, you notice that I've had to use gaffer tape around here just to hold it together. So clearly, in order to make this viable, Either you stick with the tape if you're happy with that, which is okay, or you make some kind of box. And I think someone that had made one of these, which I'd seen, I think on Hackaday, had put it into a nice plastic enclosure. Had used a cutter to cut out a space and so on, and got that in there with a couple of banana connectors. And that's okay, but the real thing that worries me about this is, first of all, the power handling of the resistors. Because of the size limitations, I'm limited by the size of these switches. We've only really got 125 milliwatts of power handling capability, and these things will be pretty easy to blow up. I've also found that in testing that some of these switches, they're not 100% perfect. It takes a couple of goes to get a good connection. So should I damage this, it's going to be really difficult to repair, because I'll have to basically take it apart. I'll have to disconnect the, find the one that's at fault, depending on which decade it is I've broken or I've burnt out. Take it apart, find the resistor, replace the resistor, put it back together. I mean, not the end of the world, but I don't think it'll take too much of that. I mean, this is all quite flimsy and so on. So, and I'm not 100% sure these switches will be that reliable. I'm sure they'll be fine. And again, I will hang on to this, and I'll probably build a couple more of them anyway. But what I wanted to do was see if I could find a solution that was perhaps a little bit more geared. And the other thing, sorry, that's probably worth mentioning is obviously I've soldered a couple of hookup wires here. So I've somehow got to get these wires into this prototype board, and the obvious thing is to just tin them, which I haven't done. And use them, and when you tin wires, that'll tend to break off a bit. So I could the other option is I could solder these to it, I guess, which would be also okay. I could cut one end of that, and these are the wires that you use on these breadboards. Anyway, I just I don't know. I'm not 100% happy with this. So I thought what I'd do is I'll do something really quick and dirty, which is what I've done, and I'll actually make. Excuse me. I'll actually make a decade resistor, and I came up with this. So really nothing complicated at all. You can see at the bottom there, it's a 7-decade resistor. To keep the cost down and to keep it really, really cheap to build, I decided to use surface mount resistors and jumper, simple jumpers, simple, easily available, highly available, very, very cheap, very, very low cost jumpers, and pin headers and jumpers. And I was able to locate resistors, of the right size. There you can see the back of it there, with a tolerance of 1% and half a watt. The main thing with this though is it's really easy to repair. If something goes wrong, there's nothing to take apart. You can just change those resistors. Very easy to find the resistors because they're all on the back, the damaged one, and change them. And really cheap. This is not a very expensive construction because of the simple components. There's no switches, there's no complexities, and there's really what I like about this is there's nothing really to go wrong, which means I can. And the other thing, of course, is the size. So haven't quite managed to get the compactness of this, but the size is convenient, and for doing the kind of prototyping work that I'm talking about. On these boards is actually incredibly convenient because you can have these dotted around the edge of the circuit. You can have them plugged in just on their wires and so on. Another thing I'd done when I designed the board was I also made, although I had these made actually, I'll come on to that in a second. I had these made or hand assembled. I didn't try and assemble these myself. They had to be machine assembled to get the costs where they needed to be. But so I just had these two pin headers by default because they're easier to hook up to. If you need 4mm leads, then you can put the leads on there. If you need these things, you can put these things. They're nice and convenient. But I did, if you look at the back there, I did actually also get holes drilled, which allows you to remove that header and just put on these standard 4mm banana jacks. So it's very easy to change to that format as well. And I'm sure both will be useful. Both will be useful to have lying about. So anyway, so I've made those, and because I've made a whole bunch of them, I am going to make some of them available to buy on eBay. And I'll put the search term up in the text, so you can just search on eBay for the search term, and you should be able to find these. Or in fact, you should be able to just search for jerrysweeney.com. And that should also find them. So if you're interested, feel free to to grab one and if they're of any use to you. Okay, so that was it. It was really a simple project, nothing complicated. I just wanted to talk you through it and talk you through the rationale. You know, why go to the trouble of making something like this. You know, in summary, this is how it is. There isn't anything cheap that's convenient that you can just buy and use. And I don't know about you, I don't mind, you know, taking on little projects and building little things like this. But, you know, my time, you know, I like to spend my time on productive things, and I think, you know, soldering 90 resistors to some switches and bits of wire, you know, it's just an awful lot of time, and it's okay if it achieves an end goal, but it's really time that shouldn't be necessary. I really hoped, you know, I was really looking for something like this around, and there wasn't anything, so I thought, I'll take the initiative and I'll build them myself, or I'll design them myself, get some made, and then if anyone wants them, they're available. Okay, so thanks very much for watching. If you found it interesting and you like the project or the idea of it, please give it a thumbs up, and I'll catch you next time. Bye bye.